Okay, we're looking pretty sparse out there. A combination between the snow and homework 1 due, I'm sure, is doesn't help at all. So let's go through this. Let's talk about file uploads. And since homework 1 is due today, does anybody have any burning questions that aren't appropriate for like Piazza and office hours, but something that might be relevant to everybody? Yes.
How come in your example code you did if boolean return true, else return false? I'm still upset about that.
What do you mean? Where?
Garbage code in your example.
I have a lot of garbage code in my example.
If else return false.
I have a lot of garbage code in my example, though. Which one? Because the examples aren't meant to be copied verbatim. I'm showing the concepts. This is one of my sources of frustration. Every time I show code, you all copy it down character for character, and then ask me why it doesn't work. What example was it, though?
It was like the reject syntax, like the raw patchy rejects. It was, yeah, you have if boolean return true, else return false. You just return the boolean.
Oh, because I got 3 different cases. Oh, yeah, I see. Right here, this should be just return search results. Yes. Why do I have that there?
Well, the search result actually is not a boolean, but you're converting it to a true value there, so you could just
Thank you. Thank you, Nicholas. Yeah, because I can't, because this isn't a boolean, because it's the result of a regular expression search. So if this is not, if this actually has results, then I'm returning it. If it doesn't have any results, then it's false. Yeah, thank you. I'm like, why did I do that? That's exactly why. Excellent question, though. I like it. That's always a valid question. Why does your code suck so bad? Sometimes there aren't good answers. All right, anything else? Okay. Actually, do want to be in this code a little bit. Something I keep forgetting. I keep getting this question. I keep forgetting to talk about it. So in our code, especially in our database, we have an external library that we need, PyMongo. This is not part of Python. So we do need to download and install this dependency. And in my Docker file example, I had this line. A lot of you have been deleting it because it'll cause errors, because I never talked about requirements.txt. What this line does is looks for a file named requirements.txt and then downloads all the dependencies specified in that file. So, and then I never show this to you. So you want to create a requirements.txt and then list all of your dependencies, just the dependency, one line at a time. If I had another dependency, I would say bcrypt. PyCharm even knows what to do, and I can just install bcrypt, and that's done. And then in your Docker file, you need those dependencies installed in Docker. That's what this line is doing. It's saying, download all my dependencies so I have what I need inside this container. Without that, you're always going to get errors on importing PyMongo. And it's one of those things where you probably got the error and then fixed it locally, installed it with pip, and then when you go to run in Docker, it says, PyMongo not installed, PyMongo doesn't exist. That's the solution to that. Keep this line in there, set up your requirements.txt, and just put your PyMongo dependency right there. Yes?
Can we just have more run statements in the Docker?
Yeah. You don't have to do it this way. This is just one suggestion. So you can put run in your Docker file. You can do run pip install PyMongo, run pip install bcrypt, run pip install whatever. That's fine too. But it's nice to keep them. It's just good for organization to keep them in the requirements.txt. If you don't want to do that, I ain't stopping you. Was there another question back, or was it the same question? Assuming it was the same question. All right. And that's true for anything in this course, by the way. Well, I guess there are probably a few exceptions. But I'm showing you a way to do things. If you want to get the job done, if you want to complete the objectives in some other way, as long as you're not like importing HTTP libraries and things like that, things that are explicitly banned, as long as you're not doing that, just get the job done however you can. I'll show you one example of how to do things. In most of my examples, I'll see after tonight what language y'all are using. But most of my examples are in Python. I'll assume most of you are going to take my advice and use Python. But if you're not using Python, you don't have any examples to go by, at least so far, aside from a little bit. So I don't expect you to just copy what I'm doing. That's not what this course is. That's not what this course is about. It's a 300-level computer science course. It's not copy code from the projector in the lecture videos course. That said, the code that I do show in lecture, you're free to copy it. You're welcome to. That's kind of why I do show it, but it's frustrating when I see copying character for character. And I don't know. I don't want to talk about that. So get the requirements.txt if that's the issue that you're having. So I do have this server running, and oh my God. And I cut and pasted that form for homework 2 into the sample code. Same thing I expect you to do, just plop that code right in there and go. Unless you built your own custom page and you want to make things more interesting than this kind of meaningless page. I'm going to type, I don't know, hello world. I'm going to choose an image. I'm going to be careful to choose an image that's text. I'm going to send functions.js. I'm going to upload this file. Now, my server doesn't do anything for this path right now, but what I want to do is show you what the request is going to look like. So that form creates a post request for image upload. Oh, I thought did I change this? It's not worth changing right now. And I'm printing the bytes, not the decoded string here. Image upload, I have headers. This header in particular, content type, is going to have a boundary. And we're going to look for that /r/n/r/n right here. That's the end of the headers, the start of the body. And then we're going to see all the parts of the form. And we can see in here the content that I uploaded, hello world, and then also the JavaScript file that I uploaded, the content of that file. So I can see all of that information in my request. What we want to do today, and notably a trailing, I always forget about this trailing new line at the end. What we want to do today is figure out how to parse requests of this type. And I'll also answer the question, you know what, let me do it right now because then I don't have to come back to the code. If we upload something that's not text, which my server will probably crash. Well, something that's small enough. Not that one. We can see that we get all the bytes of that file. Well, not all of them because my server's not ready for this yet, but all the bytes of that file printed to the screen, and that's why I'm not decoding as a string. If I upload something that's not a string, I want to actually see the bytes of it and not crash. So this is the format that we want to parse. That's what we're going to talk about all day today. Yeah, so I don't know if I like it. I was, so I spent a while yesterday improving the style of my slides. And I went to download them right now. I realized the file is 5 times bigger than it used to be because of the textures and stuff. So I don't know if, okay, we'll see. I'm playing around with things. I like this. I like the styling of this, but I'm not thrilled about the file size. All right, so let's talk about these post requests. And the ultimate goal today is talking about how to upload images to our server. We're talking about Objective 2 at this point. We're going to say just about everything you need for Objective 2, except a deep dive into buffers is going to have to wait till next Wednesday. Other than that, this is everything that you need to know to get Objective 2 done. So from last time, we're going to set the encoding type to multipart form data. This is going to give us requests in the format that we just saw in the browser or in the terminal, where each input of the form is a separate part in the request, the body of the request. And that gives us this, not as bytes, but as a string, decoded as a string, so you can see, so you can't see every character. We're going to get it in this format. And this format is required for file uploads. When we want to upload files, we make one change. Type, instead of text, we just change that to file. That's it. When I just did that demo where I clicked choose file and my file picker came up and I chose a file, that's all browser, that's all operating system. It handles all of that for me. All I did is type equals file. All the other functionality is just there. That's why the file picker looks the same on every single site you've ever used ever. It's because that's built into the browser, and the browser talks to the OS to be able to navigate your file system by having an input of type file. That's not part of the code of the website at all, because goodness, if we let websites navigate our directory structure and our files, we're in big trouble. They can't do that with code. We can't do that with JavaScript. Can't do that with HTML or anything. We just say, hey, browser, I want this to be a file. Let the user choose a file in a secure way, and then let me know what the bytes of that file are. So really easy for us. Type equals file. Done. This form supports file uploads. So we support file uploads on the front end now. That part's easy. What do we do on the back end? So on the back end, we're going to get the body of the request looking like this now. We're going to have our boundaries, our name, commenter of Jesse. That's the same. This form's a little different than the homework form, of course. Not comment, but commenter. Put your name and then an image. And then for the file, we're going to get not just the name of the input. So this matches the name that we gave the input, but we're also going to get the name of the file that the user uploaded. For this class, and I think for most cases, you're not going to care about whatever the user named this file. You're going to apply your own naming convention to these files. If you ever upload a file to the internet and you try to download it again, you'll notice it has some long cryptic, like hashtag-looking, hash-looking file name. It's not going to be named whatever you uploaded it as. Because what if two users upload files with the same name? Well, there's a conflict. So every server needs a naming convention. So they just throw this away. But we do get that information if you ever want to do anything with it. We get a content type, and then the bytes of the file. The actual bytes, we saw this in the browser. The actual bytes of that file are right in the HTTP request. And this is something that if you're not familiar with this stuff, it takes a little bit. I think it's exciting though, but it takes a little bit to really realize that files are just byte arrays. So we can take the entire contents of a file and just throw it right in our HTTP requests and HTTP responses. We can store them in byte arrays. Like a file is just a sequence of bytes. There's nothing really special about files. They're just a sequence of bytes or a byte array saved to disk. So we can take the bytes of this file from the request, read those, and then save them to a file. And I gotta look up one thing because I always forget this. I always forget if there's a trailing new line. Yes, there is. So there is a new line at the end of each of these. I'm glad I have this request right here so I can check. That'll come up later. I'll go through this line by line. Oh, no, I don't want that. Oh my goodness. How do I get back? So the bytes of the file are going to be right in this request. And this will be a new line character. That's what I was just looking up. I just wanted to confirm. I was like 99% sure. I wanted to make sure. There is a new line at the end of the bytes that you have to take care of. So the bytes are, the file is just bytes. That's it. We deal with bytes a lot in this course, and that file is just bytes. So far, all of the bytes that we've handled, except for the files that we hosted, have been UTF-8 encoded bytes. So they were strings, but they were encoded using UTF to get a sequence of bytes. But not so much anymore. When we get files, when we get multimedia, when we get PNGs, PDFs, zips, movies, Whenever we get these, they're not UTF-8 encoded. They're just the bytes of that image, that video, that zip file, that PDF. They're just the bytes of that file. We can read the bytes of that file and just save them to disk. Wait for other users to request that information, read that file, read the bytes, send the bytes to that user. It's all just bytes. So when we have a file upload, this is going to be like the full request, and this is what we'll go step by step through and figure out how to parse this thing. This is going to be the full request that we'll need to parse for Objective 2 in the homework. And Objective 1, it'll be mostly this, but you won't be concerned about the bytes of the file at that point. So this is what we need to parse. Are there any tips for the buffering goal? Oh yeah, I got a whole lecture about that. Or I guess half a lecture. I got something else planned for the other half of that one. Oh. But it hung up on the way. So assuming you're using Python with socket server, you're going to want to enter a loop. So as soon as you get to the end of the receive method, the TCP connection is closed by your server. So you want to enter a loop, receive the data, check the headers, read the content length, and then enter a loop that says, well, I haven't read all of the content length number of bytes from the body yet. Keep going back to the TCP socket and call receive again. Keep reading bytes, and appending them to a byte array. And then once you have that many bytes read, content length number of bytes, then get out of that loop and then start parsing everything. If you reach the end of the method, it's going to close the connection. And then you're going to lose information. You're going to lose data. So that's my TLDR on it. Are these slides sponsored by Wrangler? Not sponsored, unfortunately. It would be nice to supplement salary, though. All right, so first thing, post in /form path. This is going to match whatever you have in your HTML. You're going to have your method and action. That's where this is going to come from. Whatever you have there, that's what's going to show up right there. Whatever you name that action, that's the path that's going to be requested. In our HTML, we had action equals /form path. That's the path that's going to be requested whenever we get a submission from this form. Content length is what I was just talking about. Content length is going to be very important here. For this sample file, this discord.png, very small file. It's just an icon. It's the Discord icon that's on the course website. It's not that big of a file, but 9937 is going to be larger than your 1K if you're using my lecture examples, where you're reading, when you say receive 1K 1024, that's saying read at most 1024 bytes from the TCP socket stream. Well, this is more than 1024. It's even more than 9937 when you add the headers. The content length is only the number of bytes in the body, it does not count any bytes in the headers. So we have more than that. We have more than 10K bytes here, probably. So you're not going to read all this in one go. That's the buffering that we'll talk about in a little bit. So you want to parse this content length. You do have to parse that. Parse content length, figure out how many bytes you need to read. Read from the body, count the number of bytes you've read from the body. And if that's not equal to content length, you need to go back to the socket and read some more information. You need to keep calling receive and get more and more bytes. In Node with JavaScript, this is a little bit different because that method is called for each time data is read from any TCP socket. So you do have to have a variable that's going to store your buffered bytes and actually reach the end of the method. It'll be called again and then check, is this the same client? Which you can assume for homework 2, it's the same client, and say, okay, I'm expecting to read more bytes, append these bytes. If it's up to content length, now start parsing the request. So there's a bit more work to do with buffering. We'll talk about in depth next week. So content length, number of bytes of the body. And then content type, we also have to parse. This is going to contain the boundary that we need to read. This boundary is going to be the boundary between the parts of the multipart request. This is shown in the same format that we use to say, hey, this is UTF. This is text/HTML, semicolon. I shouldn't have went down this road. I forget. But something equals UTF-8. I don't know why I'm blanking on it. But anyway, same format, boundary equals WebKit boundary, blah, blah, blah. It's going to be the same thing. We'll see this format again when we talk about cookies, to add directives to cookies for what it's worth. But we're going to see this format. The content length is only the bytes of the body. I already said this, but it's worth repeating because this will still be questions in office hours. Content length is the number of bytes in the body, although those questions will probably come from the empty seats, I would assume. I think that's a safe assumption for the most part. Content length, number of bytes to read in the body. Read that many bytes. If you haven't read that many bytes, don't start parsing the body. You don't have all the bytes of the body yet. This is actually going to be important even for Objective 2 without large images before you get to Objective 3 for some browsers. Some browsers, I think Chrome is one of them, so it'll affect most of us. When you upload a file, Chrome is really quick to send the headers over the TCP socket and say, here are your headers, like right away, while it's reading the file. And then once the file is read and those bytes are ready, then it says, oh, by the way, here's the body of your request. So when you first receive bytes, when you first read bytes off the TCP socket, it's common to only have the headers and the blank line, the /r/n/r/n. It's common to only have that and have a 0-byte empty body, apparently at least, and you have to read the content length, make sure you've read that content length number of bytes, and if the content length is not 0 and you have 0 bytes read, go back to your TCP socket and say, hey, you got more bytes for me? And it'll say, oh yeah, I got your actual content. And then you can start parsing. So even if you're uploading an image that's like 5 bytes, you might see that in certain browsers, certain setups, certain combinations of browser and language. I think the language matters too, because it's a race condition at that point. It's whoever gets to the TCP socket first is going to determine what happens. So be cautious of that. You might see that even in Objective 2 when you first start uploading files. And as we saw, I didn't have that issue with Opera. Opera did send the whole thing. But I think it's Chrome. Chrome has like ridiculous amounts of optimization built into it. And that's one of the things that it's optimizing, I believe, is what's happening there. And then each part of the request, each part of the body is going to have its own section. For our homework, until you do Objective 5, it's going to have 2 parts. And each part gets an entire section of the body. They're going to be separated by the boundary, but it's not exactly the boundary from the header. I don't know why they do this. This kind of drives me nuts, but it's the boundary with 2 leading dashes. I don't know why, don't ask me. Somebody decided this is a good idea. I have no idea why. But it's going to be this boundary, which starts with 4 leading dashes, but when the boundary is actually used, there's going to be 6 leading dashes. They do this, I think they do this just to annoy us, just so there's one extra step in our parsers that we have to write. I don't know why they do it, but they do. So the first thing you want to do when you're parsing this stuff, read the boundary from the headers, prepend 2 dashes, and then split based on this boundary. Now, we have a guarantee from the browser that that boundary is not going to appear in any of our content, so we can safely split on the boundary. And then the last boundary is going to also contain a trailing dash dash. So if you see that trailing dash dash, or if you're splitting on boundaries, you're going to see a trailing dash dash, and then a new line character for what it's worth. And you're going to have that new line character that we just checked before this boundary as well. make sure you don't interpret that as part of the bytes of your file. So you got to look for these boundaries with all the extra crap that the browser is going to add around this boundary, the extra dashes, the new line characters. Make sure you're parsing all of that out so you can isolate each part of the multi-part request. Two questions from Soulfish. Sorry, I didn't see that. Does that count content link the WebKit? Yes. So everything after this blank line is part of the content link. So all of these bytes are part of the content link. Is there a limit to the amount of bytes that I could load in at once? I don't know what you mean by that. Like in memory? I guess no. Like you could upload a 1 gig file, if that's what you mean. Yeah. And there are practical limitations. If it's bigger than your RAM, you're gonna start. I'm blanking on the name. Paging, I think it's called. But you're gonna start using your hard drive as RAM. Once you fill up your hard drive, that's gonna really slow things down. Theoretically, you could fill up your hard drive, and then those kinds of limitations. But HTTP doesn't have any limitations on that. If I could load in the thing and then have it cut off. So that would be hard to do. Like as you're buffering, find this, you're buffering still, but you find that you read the second boundary and then start parsing while you're still buffering. You could do that, but that would be very painful to code. And you wouldn't really see much benefit from it because you still got to parse the whole thing before you can do anything with it. But theoretically, you could do that. How do we till we have 0 in the body cell when you go over? It's a while loop. So you have an array of bytes that you're reading. You read, you append, you read, you append. You build up this buffer. And you say, length of that buffer is less than content length. Keep reading. And then that loop will automatically break as soon as that condition is false. I see why form died after Ajax. Yeah, for a few reasons. Because we can't really control, if you're using an HTML form with the standard submission like we're doing here, this is the format we're stuck with. We got to use this format. That's one reason. But honestly, once you have your parser written for this format, you never have to care about it again. You just have your parser, you call your parser, and it's done. So just like writing your general code, your general structure for your project, I recommend having a general parser. For this, write a parser that's going to work for any request of this type. It's going to isolate the headers, parse them, do everything you need to do, and then start handling the request itself. So then every time you have a form submission, you don't have to modify everything. Specifically, when you get to Objective 5 and you have to add a third part, what students like to do is just kind of find the data in the order that their specific browser puts it in and says, the first one I know is going to be the comment, so I'm just going to assume that it's the comment and et cetera. And then they get to Objective 5 and they add the cross-site request forgery token. And then there's 3 parts to their form and their crappy code just blows up. Just write a parser that parses this, gets all the information you need, and then start handling the requests is a much better approach. But I know a lot of students don't follow that advice. Or rather, the ones that follow that advice, I never get to see in office hours because they don't have issues. But each part of the multi-part request is going to look similar to an overall HTTP request. You're going to have headers, any number of headers. So that general header parsing code you wrote, just throw it at this. Okay, I got headers. Look for that new blank line. Everything before that blank line, it's headers. Parse them as headers, throw them in your header parsing code. Done. Assuming you wrote that. This is another case where that's going to save you a lot of time if you wrote that code on homework 1. And then one blank line, /r/n/r/n, just like an HTTP request. These are basically HTTP request formats. There's just no request line. And then the bytes of the file. or the bytes of whatever in the body. Up until a new line dash dash boundary, up until that's the body of that part. In those headers, there's going to be one required header, content disposition. This is similar to our content type in a way. It tells us some meta information about the content. Most importantly, I shouldn't say most importantly, but including the name from the HTML element. So whatever you name that HTML element, that's going to appear in your content disposition under a name equals, and then in quotes, the name of your input. So parsing that is going to tell you which part of the form you're currently reading. And for files, you're going to have an additional file name that I mentioned earlier. You can have any number of additional headers, content type being one of them, if the mimetype is not plain text. So by default, it'll be plain text. So here we have no content type. That means this is just plain text. The user types something into an input, and we got that plain text. If the content type is different, it's going to specify it in an actual content type header. The content length does not appear in each part. The whole point of content length is to make sure we read all of the bytes from the TCP socket. Because TCP sockets are streams. They're just streaming bytes constantly, potentially. And we want to make sure that we've read from that stream long enough to be able to get the entire request. Well, that's already happened by the time we're parsing the body of this multi-part request. We know we already read all the bytes, so there wouldn't be any point to having content length again. There's no purpose to it at this point. So there's no content length in these parts of the multi-part request. And we have bytes to a file. This is probably the big thing that makes this more complicated than it appears at first. Because so far it's a bunch of string parsing. But we have bytes of a file. Now, when you were sending the bytes of a file, of an image file, in homework 1, you knew it was very important to never convert those bytes to a string. The same thing is true here, except the bytes of this file are surrounded by a whole bunch of stuff that we seemingly need to parse as strings. So now instead of taking the bytes of an image and just concatenating them to our other strings by converting the headers and stuff to a byte array and then combining the two byte arrays and then shipping it, instead of doing that, we have the bytes of this file really nested inside all this big mess of a request. And we have to never, ever convert that to a string, but we have to do all this parsing. How are we going to do that? Oh, my. And the answer is parsing bytes. So instead of doing string parsing, we want to start doing some byte parsing, which isn't too much different than string parsing, but we need to do byte parsing. So the first thing we want to do when we get a request like this is look for this /r/n/r/n and isolate the headers. The headers we know we can parse using UTF-8 or ASCII. They have to be ASCII characters, so either encoding is going to work for us. So we're going to look for that blank line, the first blank line, and then take whatever's before that. That's a string, and then we can convert that to a string and start doing our string parsing on the headers only. So we're going to take this sequence of characters, convert it to bytes, convert that to a byte array in Python, encode it, convert that to a byte array, and then look for that subsequence in the byte array that you received in the request. Look for that subsequence and find the index of it. Usually it's .find in most languages. .find that subsequence, the first occurrence of that subsequence, and then everything before it, slice your array. Everything before that's your headers, and you can start parsing that. Everything after that is your body. So look for this as bytes, get the headers, and then parse the headers as ASCII or use a UTF-8 encoding. will work. So now we've isolated the headers. We can parse those the same way you did in homework 1. We isolated those from the body. Read this boundary, and then when we get the boundary and we prepend the dash dash and we want to split all our content on that boundary, well, we can't just do string.split on this boundary. We can't do that. We're in the world of bytes. So what we want to do is look for this sequence of bytes, convert this with the prepended dash dash, convert that to a byte array, and then look for all occurrences of that in the bytes of our body of our request. We're going to look for that sequence in bytes and then chop up this request, the body of this request based on that. So we want to isolate, in this case, these 2 parts as bytes before they've ever been converted to strings. Now, the first one's easy. It's all a big string. We can convert it to a string, and we're done. Assuming we know that it's the commenter, we'll do the same thing that we're going to do here, but once we find that it's the commenter, it's a string, we're going to handle it all as a string. But this one gets trickier. For this one, and you'll want to do the same thing for both, but this is the one where it's most important, is we want to look for that blank line, just like we did in our first step. We're going to look for that blank line that we know exists. Everything before it is going to be headers. If we find out that it's the commenter, then we can parse it just, it's strings. We know how to handle strings at this point. But if we find that it's the file, now we got a little bit extra to do. Well, I guess not really. But we want to split it on this sequence as bytes, read the headers, parse all the headers, figure out that we're looking at the file, and then once we know that, we finally have the file, the bytes of the file isolated. We parse everything around it. We parse the headers. We parse the boundaries to get the separate parts. We look for this blank line, parse these headers, all that converted to strings, and we never converted the bytes of the file to strings. This is one of the big challenges of this homework, how to never convert those bytes of the file into a string and get everything else around it out of there. And at that point, save those bytes to a file, come up with some file naming convention. Image 1, image 2, image 3 is fine. Save those to disk, and then when somebody requests the home page, read up all your files and serve those in your responses. And we now support file sharing. So there's a lot of parsing. Like, the format isn't too complicated. I mean, it is and it isn't. But writing your parsing code for this does get involved. This is the first big difficulty of this course as well. Objective 2 on homework 2, that's where it starts getting real. So just be aware of that. I don't think it's too, it's a lot, but no single part of this is overwhelming. It's a lot, but it's just something where you got to sit down and think it through, write good code for each step of this process, and then get the job done. There's no one step in there that's like, holy crap, how do I do that part? I don't know, maybe there is. Depends. Depends on your background and your level of comfort with bytes. Is /user/ the same as just /users? Not really, but if you code it that way, I suppose that would work. If there's an ID, so the big question with this one is, how do I figure out if a GET request is for all the users or for one particular user? The guaranteed answer is if it's /user/ and then anything after that second slash, then you know it's a request for a particular user. But if it ends in a trailing slash or not, those are different paths. But if you want to be absolutely sure, check if there's a second slash, there's something after that second slash that's not the empty string, then you know for sure. Otherwise, you can handle it as a request for everything, for all users. Could the bytes of the file and the body potentially have a sequence of bytes that happen to correspond to /r/n/r/n by coincidence? Yes. And that is an excellent question, Rob. Absolutely yes. And next Wednesday, when I talk about buffers, that's actually going to be part of my demo. I'm going to do a demo showing exactly that. This is something that trips up students each semester. I'm going to prepare a whole lecture demo to make sure nobody falls into that trap this time. So the question is, the issue is, if you have a request like this, and the first thing you want to do is request.split on those blank lines, those /r/n/r/n. And you think you're going to get this, this, then this, then this, then this. You think that's what you're going to get, and then you start parsing based on that assumption. Well, what happens if the image itself contains that sequence of bytes? It's very possible that it just happens by coincidence. And some students will get a test image with that, and it exposes that bug in their code. And this semester, I'm going to show you that explicitly, and you better believe we're going to test with an image that has that subsequence of bytes. So that is something we'll talk about Wednesday. So you can't do .split. Just in general, you shouldn't use .split unless you know you can use .split. Like, for example, you have all the headers, and you want to split on /r/n. That's fine. That's fine. But once you have the bytes of the file and you're splitting on a certain byte sequence, that file might contain that byte sequence just coincidentally. And that's something we have to be aware of. Can we split on the byte array like we do strings? It's going to depend on what language you're using, if it has that functionality. But at the very least, you can do find in a byte array and then write your own loop that effectively does the splits. But again, like we just said, you have to be a little careful with how you do that. The WebKit, the boundary here, this is guaranteed to not have that problem. So you can safely split on the boundary. So all this crap over here, that was generated by the browser, looking at what the user submitted, looking at whatever they're uploading, and then generated this to guarantee that the boundary is not going to be contained in whatever data the user uploaded. So that you can guarantee. That's part of the spec. It's part of multi-part form encoding. The browser has to enforce that. If the browser doesn't do that, the browser didn't do its job. So whatever this boundary is, it can't be contained in the data. That one we can guarantee. /r/n/r/n, not so much. We can't guarantee that. So we support hosting files now. We have an image upload site after you code all of that. Users can post their images and share them on your site. So this implies that we're hosting files that were uploaded by users. And there are some things to think about with this. One, you should have some naming convention and some URL scheme. Probably this one, just image/image name. You can use your code from homework 1. You already have the code that hosts images. Just use that code. If you want to do like a query string, knock yourself out, that's fine too. But this one's probably the one everyone would choose. I would assume it's a lot easier. Once they request the file, send the bytes of that file in the response, just like you did in homework 1. And you can send a 404. I don't have anything in the homework 2 spec that says what you have to do if an invalid image is requested. It's fine if you don't send a 404 or however you want to handle that. It shouldn't crash. Oh, did I even put that in the testing procedure? I suppose if it crashes, you probably don't lose points because I don't think I put that in the testing procedure. But a 404 is usually what you want to do. Check if the file exists. If the file doesn't exist, respond with a 404. But we do have a big concern with security. So this implies that you're going to have somewhere in your code, check for a path that starts with /image, take whatever's after the second slash, take that as the file name, and then go to my hard drive, read that file, and send the bytes of that file back to the user. This is roughly what you have to code, something to this effect. And it's fine when they start requesting images that exist, but what happens when they send this request? Well, if they start typing any file path they want, in that URL? Well, in this particular request, the user might have just stole your private key, your private encryption key. And that's something we don't want to happen. We don't want the user to be able to use this path to request arbitrary files on your server's hard drive. It's a very big security concern. Luckily, we have a pretty easy defense against this, and this is what we'll look at for grading, is do you ignore slash characters? If you don't allow slash characters in these paths, the user's very limited to what they can do, and they can't escape, at least not easily, they can't escape the image directory where you're going to go to read these images. Without slashes, they can't really navigate your directory structure. So when you're hosting these files at this path, don't allow slash characters. One way or another, make sure you handle that. The quickest, dirtiest way, find and replace slash with empty string, done. So we'll look for something like that, something to that effect to make sure that you're not allowing arbitrary files to be requested by the user. You can get stronger than this if you want to really make sure you maintain a list of valid file names and then only allow files with that name, and then respond with a 400 level response if a different file name is requested, probably a 403 forbidden, hey, what are you doing? Or 404 not found if the file doesn't exist. And don't forget your mimetype sniffing. This is where that really comes in handy. The users at this point can just upload a JavaScript file using your form. That's what I did incidentally in the demo at the beginning of the lecture. I uploaded a JavaScript file using that form. Well, if you're hosting that JavaScript file to all users, you want to make sure that it's not going to be executed by the browser. So put your mimetype sniffing, turn that off. The mimetype is going to be image JPEG, and the browser's not going to interpret it as JavaScript. In 2 minutes, I don't have time to do any more demos, so let's just do lecture question. And then once you submit, you're free to go. Do we have anything like string builder in Python? Maybe. I don't remember. I'm sure there is, but I don't know off the top of my head. So why can't we store the files in the database? You can if you want. That kind of goes along with however you get the job done, you can get the job done. You can store the files in the database if you want. Typically, you would store the files in a directory structure. Just store them on your hard drive directly. And then in the database, store the file names. You would store comment and file name. And then when you read from the database, you got the comment, and then look up the file name, go to your hard drive to open the file to get the bytes of the file and combine those. If you want to store the bytes of the files directly in your database, I'm not going to stop you. But typically, that's not the way it's done in practice. Databases weren't really meant for just large file storage. Oh, Nicholas has the answer. I should read the next comment before I... You don't want to bloat up your database with stuff that database isn't good at handling. Databases are really good for indexing. They're not good for mass storage.